Okay, well, so here we are, curve sketching, and this is take two on curve sketching for me. I got to about the 18-minute mark, and my technology went haywire, and I was at 18 minutes, and I wasn't quite done, and so we're starting again. So here we go, curve sketching. So all these things in black are things that you've learned about before coming to calculus. We've known about domain and range since we'll say Math 1. Maybe it was later for you guys, but we know we introduced that now in Math 1. X-intercepts and Y-intercepts, Math 1, Math 2, someplace in there you've learned about that when you started graphing from standard form, vertical asymptotes. I don't know, maybe those showed up in pre-calc. I'm not sure. But all this stuff, critical numbers, increasing and decreasing, max mins, points of inflection, concavity, and your horizontal asymptotes, that's the stuff that we've been talking about lately. So what we're going to do with curve sketching is we're going to give you an equation, and you're going to use all these math things in your power to come up with the equation. So we're going to start with x to the fifth minus 5x, okay? So in terms of domain and range, nothing really new there. Domain range, all real numbers, okay? So we'll just put all real so we don't have to restrict anything. Remember, I only really worry about domain and range when we're looking to restrict values from it or when we have to. Okay, x-intercepts, y-intercept. My y-intercept happens when x equals 0. My y-intercept is going to be 0 in this case. When x is 0, we're there, okay? Let's get to the calculus part of things. So here we go. First derivative, f primed. See if we can't find us critical numbers. 5x to the fourth minus 5. So let's see if we factor a 5 out of that. That leaves me with x to the fourth minus 1. Give me, when x equals 0, I get critical numbers of plus minus 1. Okay, this factors as x squared plus 1 times x squared minus 1. So critical numbers, x equals plus minus 1. Okay, so we're going to store those away as we go. Second derivative, f double primed of x, that's going to be 20x cubed. When is 20x cubed equal to 0? Well, when x is equal to 0. Okay, we're going to have to extend the page a little bit, and so let's go to the intervals. Okay, so interval from negative infinity to my lowest critical number or point of inflection. We're going to bounce back and forth between them. Negative 1. Negative 1 to 0, 0 to 1, 1 to forever. Okay, we bounce from critical number to point of inflection. We just kind of work our way through. Then we pick some numbers. Okay, from negative infinity to negative 1. I know you're thinking negative 287. I'm going to go with negative 2. Here I'm going to go with negative a half. Here I'm going to go with a half. And here I'm going to go with 2. Work that symmetry to our advantage. F primed at my test number. So I'm really looking at, well, is x to the fourth bigger than 1? Because that's the only thing that we're worried about. So negative 2 raised to the fourth power is certainly going to be bigger than 1, so we're positive. 0.5 to the fourth power is going to get smaller. Subtract 1, we're negative. Same thing there. And then on the other end, positive. Second derivative, double primed. Well, if we cube something, if we cube a negative, it stays negative. If we cube a positive, it stays positive. So this is going to be negative, that's going to be negative, that's going to be positive, that's going to be positive. What does all this mean? All right, it means we get smaller and smaller pictures each time we go, but we can make that work a little bit. It's really hard to see. It means that we have ourselves an increasing function that's concave down. We have ourselves a decreasing function, still concave down. We have a decreasing function, concave up. And we have an increasing function, concave up still. Okay, we went from increasing to decreasing. My first derivative changed sign. So I have myself a max right here. I have myself where we went first derivative changed from negative to positive. I have a min right there. And my sign of my second derivative changed, so I have a point of inflection at 0. Okay, so we need to know moving forward the f of 1, the f of negative 1, and the f of 0, not necessarily in that order. So the f of 1, well, 1 to the fifth is 1. 1 minus 5 times 1 is 1 minus 5. That's negative 4. So let's put that in here. When 1, negative 4, we know the curve is passing through that point. The f of negative 1, so I'm going to get negative 1 minus negative 5, so that's like negative 1 plus 5, so that's like positive 4. Oops, up here. Positive 4, so 1, negative 1, comma 4. That's another point. And the f of 0 is 0, so we're going to go through there. Okay, so now let's try to make this work out. we're looking at an increasing function concave down. I can't draw them upward to make them look nice, so it's an increasing function concave down, like so. Okay, it keeps getting wider and wider. And then we've got a decreasing function concave down, so we smooth out the curve. Now we're heading towards that sort of concave down. It's hard on this small scale. Then we've got ourselves a decreasing function that's concave up, like so. And then we've got ourselves finally an increasing function concave up. If I could make that look nicer, we'd have a nice smooth point of inflection. Hits all the points that we're looking for, makes that delightful curve. Okay? All right, so there you have it. That's curve sketching, taking everything we've done, popping it into one fell swoop. Okay, this is going to be a piece of work right here. So as we look at this one, so our domain, we're going to have some issues when x is equal to plus or minus 3. True? So in fact, so much issue that we're going to call them vertical asymptotes when x is equal to positive and negative 3. My y-intercept, plug x in, I'm going to get y-intercept of 0. Okay? So let's pop in what we know. We know that we've got a vertical asymptote right there. We've got another vertical asymptote right there, dotted line. Okay? Close enough. We know that we're going to go through, my y-intercept is going to be 0, so we're going to pass through that point as well. Okay? That much we know. I'm going to go to the hover cam because the derivative of this, it's not a big deal, but it's going to use the quotient rule, so I've just kind of done them separately to work my way through them. So I can set this aside. You can't see what I'm setting aside, but I did really set something aside there. I'm going to click on the old hover camaroo, and you can see me there. I got into place. That's big enough. Let's go with that. I think you can see that. I can go full screen if I need to. Let's go full screen. That's a little bigger. Okay, so just working our way through the derivative. It's the quotient rule, right? So I've just done some things. If you really want to write this down, you can get yourself the, you can pause it and write it down, but you might just follow along through. So we did the ho-d high minus high d ho over ho-ho thing. I distributed, I expanded, I simplified. I got to the place where this is the same as that. X squared equals 0 gives me x equals 0. X squared minus 27 equals 0 gives me plus minus square root of 27. So I've got those numbers stored away as my critical numbers, places where I might have a max or a min and extrema. Okay? So good, we got those. Then we jumped ahead to the second derivative, and it's the derivative of this thing, so it's sort of a lot of work to get to that place. But we can do it. Okay, so ho d high minus high d ho, and we had to use the chain rule to get there and work there. So then I did some extra special factoring. I factored out the x squared minus 9 in both of these. So that's this one with just the 1 x squared minus 9 times this, and then 2 times 2 is 4x times that. Made it a little simpler to simplify. When I simplified, let's see, what did I do? I distributed these together. That gave me all of this piece, and then distributed into there. It gave me all that piece. Cleverly enough, what I did also was I went, oh, look, there's one of these here and one of those there, so I canceled that out. So now I'm down to cubed, okay, which impacts us a little later on. All that stuff is this. All that reduces to this. All that reduces to this. Okay, so this is my final form of the second derivative. The x squared plus 27 is never going to equal 0. So the only thing that works out is 18x equals 0, and so x is 0 is the only new point that we've picked up. The plus minus 3 we already had way back when. Okay, let's get to the intervals. All right, take some test numbers. We need a number that's bigger than the square root of negative 27, or the negative square root of 27. That's a little more than 5, so we're going to go with a little more than 5 and a little more than 6, okay? And then we're going to pick a number between negative 3 and there, so I'm going to pick, in this case, negative 5. I'm going to go with negative 1, and then I'm going to symmetricize the thing. So that's really a word just now. Okay. So when we're testing these out, we're just sort of looking, let's go further through first derivative only. Okay, if I look at the first derivative, okay, this is always going to be positive. Okay, this down here is always going to be positive. So the only thing we need to worry about is what's x squared minus 27 doing. And so essentially, if x squared is bigger than 27, the whole thing's going to be positive. If x squared is smaller than 27, then the whole thing's going to be negative. Okay, so if we look at this one, 6 squared is bigger than 27, so we're plus. 5 squared bigger than 27, not so much, so that's a minus. Okay, the 1 minus. minus, minus, plus. Okay? That's what's going on here. With the second derivative, two things that we have to take into effect. Let's see if I can fold. So this is always going to be positive because I get a positive number I add to it. This one's going to go either positive or negative, and this thing's going to alternate too. If this whole thing turns out to be negative and we cube it, we stay negative. Okay? So when we take, well, we've got -6, so that's going to turn out to be a negative on the top. On the bottom, I'm going to get a positive number. A negative divided by a positive is a negative. Okay? With number 5, -5, I end up with a negative up top. And on the bottom, I get 25 minus 9, which is positive, so I end up in the same situation. A negative divided by a positive is a negative. Okay? With the 1s, I end up with -1 on the top, or negative on the top, and also negative on the bottom. Negative divided by a negative is a positive. With this one, I get a positive up top, a negative down bottom, and I end up with a positive over a negative. So I get the negative. Then I'm back here with 5. So this is positive, that's positive, the whole thing's positive, likewise 6. Okay? What does all this mean? It means I've got a lot of dashes and dots, but right here I've got an increasing function, and it's concave down. I've got myself a decreasing function, and it's concave down. Decreasing up, decreasing down. Let's see, where are we going? Decreasing up, and then finally increasing up. Okay? I'm going to just sketch this right here, because it's sketching, and I can do that sort of thing. Okay. There's probably a couple other things I need to do before I worry about this too much. But anyway, so 1, 2, 3, 4, 5, 6-ish. 1, 2, 3, 4, 5, 6-ish. Okay, vertical asymptotes. Vertical asymptotes. There we are. Okay. We knew the y-intercept. We did all that on the other screen. Let's see, we went from increasing to decreasing here, so we had ourselves a max. We went from decreasing to increasing here, so we had ourselves a min. Concavity changed right there, so we've got a point of inflection. That's at 0. Okay? Don't need to worry too much about here. I mean, yeah, we have some change in concavity, but I think we'll take care of that with the vertical asymptotes, right? So these are vertical asymptotes, so what's going on there. Okay? So if I go back to my original function and I plug in, let's see, square root of 27, I'm going to get some number, and you know, we can figure out exactly what that is if I grab the calculator, but I have no idea where it is, so we're going to go with, well, we should do it. We should be official. What are you doing for time this time? Just for sheer craziness of it. Oh, 12:53. This is far better. We're almost done this, so excellent. All right, so I don't feel bad about actually getting a number on this thing. So the square root of 27 cubed, so second square root of 27, close parentheses to the third power, divided by parentheses, and I'm doing this a really long way. I shouldn't do this one this way, but so it's going to be 27 minus 9, so that's 18, divided by 18. So my first one is going to be, my max is going to be at about 7.79. Where is that? Oh, my min's going to be at 7.79. That's with the square root of 27. And if you believe me or not, this one's going to turn out to be at negative 7.79. So roughly speaking, someplace in this, let's see, 1, 2, 3, 4, 5, about there-ish, we're going to hit there. And about here-ish, we're going to hit there. Okay? Let's see if we can make this work out. Okay? So, you see it? Increasing function, concave down, looks something like this. Decreasing function, concave down, heading towards the asymptote, looks something like that. Other side of the asymptote, we're decreasing, we're concave up. So we're coming from the asymptote, and we're heading towards my intercept. I know that. Decreasing, concave up. Still decreasing now, concave down, so we swerve the other way. Bingo. Other side of the asymptote. We are decreasing, we're concave up, so we're like this-ish. And then we're increasing concave up, so we're like that-ish. Okay? Maybe like that. So ultimately, that is what it's all about. Okay? Taking all these pieces, putting them together in one giant, crazy thing, making a puzzle, making that thing just like that. Okay? So we've used all this calculus that we've in learning to draw a picture of a curve, to understand what's going on, what the derivatives tell us, because one of our understandings for this unit is that derivatives tell us lots of things. All right, so I hope you have questions. Oh, I know what I need to do. I need to go back here. So people will be disappointed if we don't get to the end slide, and there it is, and there's the other end slide, and there's back to that. So there's lots of stuff going on. There's lots that you can learn. There's lots that you can use. This is some good stuff as we're working our way through. Thanks for your patience. Thanks for sticking with me. This is a much better take than the first video, which you'll never see. All right, thanks. If you have questions, we'll talk about them tomorrow.